My talk is about getting a better lawn through Nerves, Scenic, and OTP. I'll talk a little about what I learned building a Nerves-powered sprinkler system. First off, my name is Powell Kinney. You can find me pretty much on GitHub, anywhere it says Kinney. I've got a couple packages on Elixir, mostly around geospatial processing. Hoping to have a couple soon about scenic components. But I was hoping to have those pushed before this talk and didn't have a chance to. And you can find me in the Elixir Slack as Kinney. Currently, I work for a small startup out of Dallas. It's an IoT startup in the energy sector using Elixir. I live in Dallas now, but actually grew up in New Orleans, so it's great to be back here. So thank you to Nikki, to Brian, and Joe for a chance to come back home and speak, especially when the Saints and LSU are doing so well. And actually remember coming to Le Petit Theater as a elementary school student for field trips, so it's very special to be on the other side of this. So a couple of things we're going to go through. First, a little bit of background and why on earth we would do this, and then a little bit about Nerves and OTP, why it's particularly suited for embedded development, and then we'll spend a lot of time on really the core of this, which is building out a scenic component. So first off, if anyone gives a talk around a small side project, something at their house, they have to obligatory why slide. But really, there's a lot of reasons why there aren't great reasons to do this. Do I need a better lawn? Well, yes, you'll see in the pictures in a second. But there are quicker, better ways of doing that. But in reality, I looked at those options and I wasn't really satisfied with the amount of control those kind of systems allow. Am I going to save money? Absolutely not. Every time I do one of these types of hardware projects, I find just I'm amazed at how my ability to find new tools to buy and new things that just absolutely make it not the financial decision. So why then do this? Well, my yard didn't look that great. I live in Dallas. Our summers typically hit over 100, and grass doesn't like that. But really, what I found myself recently on a quest to replace all of the open loop control systems in my life with tighter and tighter closed loop, automated closed loop control systems. And so my lawn was my next journey on that quest. Typically, everybody knows, plants are driven by light and water. As soon as humans get involved, we like to have a little bit of control of that. We add more water. And there's a bit of a tenuous control system that you can say most of us have in our yards where we're kind of looking at the ground, figuring out we need more water, using timers to add more water or less water to our yard. But I'm not good at looking at yard to figure out the water, and if I was any good at gardening, I wouldn't be up here giving a talk about avoiding doing the gardening. So this, to me, yearned for an automated closed-loop control. And really, I just need some science to apply. To find somewhere that someone knew better about how to make my yard look better, what it really needed. And much to my surprise and chagrin, I found those smarter people were Aggies. Texas A&M University has tons and tons of data. They do lots of research on growing crops in Texas. Lots of great papers out there, more than I could possibly need. And what I really found out was everything kind of pointed to the idea of controlling the moisture in the soil, how much water is in the soil. So great, I can add some science to this. I can tighten up the control loop. I can find a real parameter that I want to measure, find a set point that makes sense, and then control that set point. So first off, finding out what I needed to actually, what moisture level my grass needed. Need to figure out what type of soil I have. There's lots and lots of different types of soil, and I kind of figured I'd end up somewhere around here. So great. Based on that, I can actually find the amount of water my soil needs to supply the grass. And really, there's a range of water content between what they call the wilting point, which is very appropriate because that's what my grass looks like, and how much water it needs in a minimum, and then some amount of water that basically is just more than the plant can really absorb. So based on the type of soil, figured out, well, probably about 40% water. So great, I've got my set point. Now I need to know how to measure how much water is actually in my soil. And apparently the best way to do it is to grab a clump of dirt, rub it in your hands, look at what it looks like. There's a lot of very vivid descriptions of exactly what the ball of mud should look like. But the whole point is to not do this, not to get my hands dirty, not to become actually involved with the dirt. I want to do it when I'm sitting on my computer. So instead, I found some sensors that will tell me exactly what the moisture is in the water. These are capacitive moisture sensors. They actually speak Zigbee to a home automation system like SmartThings. So I get moisture data from my different zones around the house sent to this every hour or so. And then I'm using just cloud functions from Google to pull that data on a regular basis, store it into Firestore. I'm also using some local weather. So there's a person somewhere in the area that has an APRS weather station, which if you don't know, won't go too much into it. Basically, it's a weather station that transmits over local ham bands. So I've got hyper-local weather from a couple streets away, all being stored in Firestore. And then I use Nerves on a Raspberry Pi to pull that data out, make decisions on when I want to water. I have a relay board that actually actuates the sprinkler valves, I'll show it in a second, and creates water, and that waters the grass, increases the moisture level, and there I have my complete control system, control loop completed. And this is what it looks like on the wall. It's got some awesome wiring, so you can see here. The Raspberry Pi case that I use happened to have Lego bumps, and so my sons decided it needs to be a race car because race car. But that sits on our wall now and gives a nice little interface to see what's going on. So that's the hardware. So the rest of the time I want to focus on the software side. And first start off with why, at least for me, why I thought OTP was such an important or such a useful tool for this type of embedded development. And I think I would posit that the real characteristic that makes it useful is that it maintains or makes the state explicit that it's working with. So I can synchronize a software state with real-world state and make it really, really easy to see and work with. So as an example of that, as you saw, there's a relay board that's controlling all of these different valves. And a relay is just simply a component that uses electromagnet to change the state of a switch. So I can use one, basically isolate two different sets of power components. So in my case, we have a Raspberry Pi that's low current, low DC current. I can charge the coil. And then on the other side is the 24-volt AC current that the sensors use. So the valve in a normal sprinkler system basically is hooked up to this 24-volt line. It's blocking the water when there's no current applied to it. We can use a Raspberry Pi or some other microcontroller to energize the magnet inside, and therefore pulls this little switch closed, applies 24 volts, and therefore the water actually flows to the valve. And then when we're done, just de-energize the coil, and we close off the valve. So turns out that's pretty simple. Relays have very, very simple state machines. There's not a lot to it. They're either open or closed. They go back and forth. So we can model that as a gen server. So we can represent this logical control for relay as an Elixir process. So we'll kind of go through what the relay gen server looks like. Right now it just takes a channel, which is basically the pin. So I have to tell it which pin on the board, which GPIO pin. And I've got it set up so that that pin is coming out of the Raspberry Pi. The other side of the coil is sitting at 5 volts. So that once we initialize, we use this library circuits.gpio. Circuits is an awesome library for Nerves that lets you control the actual inputs and outputs of the microcontroller. They got another one for UART for doing serial communication. It makes it super easy to get started. I basically tell it, okay, open up the channel, make it an output, make it a pull-up resistor, or make it a pull-up output, and then set it high. So that starts the system up at no current flowing through the coil, switch is open, no water's flowing. And then if I send a message to this process called close, oh, sorry, and one more thing, and then I store as a state in the process the current state of the switch and a reference to that input-output pin. If I say close and this thing it's currently open, all we do is tell circuits to bring that circuit to ground, that energizes the coil and closes the switch. So very, very simple. Want to open it back up, same thing, just bring that GPIO pin back at 5 volts. The switch opens. And then finally, if I'm already in the state that I'm asking for, I just don't do anything. Lastly, what makes this really special is, well, when something goes wrong. So I have the terminate callback set up to go ahead and bring that pin back up. So I open up, if anything goes wrong, I open up the switch, therefore close the valve, not spraying water all over the yard. And then just to clean up the GPIO pin. This is probably one of those really great moments where in embedded development, I didn't have to worry about handling this case. Nerves handle it for me, or OTP handle it for me. You can spend a lot of time in embedded development just focusing on something went wrong. Okay, go figure out what the state is, go figure out how I can fix it, get it back into a new state. Here, I know it's going to do a little bit of cleanup, but otherwise, it's going to start this process up. I'm going to be back in my init, and I know exactly what the state of the system is going to be when it comes back on. It saves a ton of time. So all in all, it's a really easy implementation. This is everything we need to control a switch or control a relay. Really easy to understand. Anyone can look at it and see what that state is. And again, it keeps that state front and center. So it keeps the actual real world, is this open or closed, right there. So that's the kind of controlling the hardware side. The last piece to talk about is Scenic. The goal of this project was also I wanted to make a more functional UI. Sprinkler system UIs are pretty obtuse. I really just wanted one that showed me a picture of my yard and said which zone it was. And so Scenic is a library for building, Boyd Moulter, this library for building out client apps in pure Elixir OTP. And this is the description from the GitHub. But basically, you can build applications, work identically across Mac OS, Ubuntu, Nerves, Linux. And really, this is important. Scenic is primarily aimed at fixed screen connected devices. Hey, that's us. But we can also use for portable applications. So it's very, very versatile. It works really well for touchscreen. A lot of the stuff that comes with it is based on kind of that, a lot of it around the touchscreen controls on IoT devices or embedded devices. And it comes with a great set of primitives. So if you need to draw a line, text, circle, square, things like that, you can do that right out of the box. It also has a set of common components like buttons, sliders, things like that. But you can also build your own components and build your own reusable components on top of those. So if we look at, I won't go too much into setting up Scenic. There's great tutorials online. It's very simple. And even the generators that come with Scenic actually come with a specific generator for generating Nerves project with Scenic in it. So it makes it really straightforward to get started. But all of the drawing, all of the rendering is based around a graph, modifying that graph and then pushing it to the viewport, and then later on, again, keep modifying that graph. And if we look at this UI home, which is the root that actually draws this, the main application, all we're doing is say, hey, build a graph and put this relay control, which is what we're going to build, add it to the graph, and the translate just tells it where in the screen to go. So I translate over 283 pixels just to put it in the center. So the actual component itself uses Scenic component. Like I said, uses a lot of the same primitives and components. We usually pull those in just to make it easy. But it starts with this, this nice piece of API that basically you're going to pass it data to start that, to initialize that component. And I have to provide functionality to verify that that actually is valid before it will display. So in this case, I want an integer. The relay number, I've only got 8 relays, so I want to make sure it's between 1 and 8. And if it is where I want, then I just reply with it. If not, reply in valid data. And this info message that I create here is actually displayed on the screen. So when you're working on it and you're actually debugging, besides Nerves having a great development story as far as being able to push over the Wi-Fi to your device, you actually get the errors displayed on the screen of the device. You can tell it to start over. So you can tell it to reset that particular screen. You can tell it to try again. So that's the beginnings of it. Next, we need to actually initialize the component itself. So again, it's the same thing. We have a graph, and we want to add things to it. So in this case, I'm adding a rounded rectangle, telling it how big, how to draw it. I want to add some text. Again, telling that translate. T is a shortcut for translate to tell it where on the screen to go, really where within the component to go. Another text for open. And this time I'm actually given an ID so that later on I can reference that particular text component. An open button, and I can give it a theme and make that one different color than the close button. And again, I have an ID for each one of those. So you'll see in a second, we'll need to know which button is talking to which button we're changing. And then finally, at the end, I push that graph to the viewport. And then I set the graph as the state, so I have that graph to work with later. So that, if I just run this, sets up a nice little component in the middle of my display. And then I want to do something with it. So like I say, each of these buttons has an ID. I can then, inside the component, filter. It's called filter event, basically the same thing as responding to a message from the front end. In this case, we'll get an event called click. It'll tell us the ID of the item that sent that event. There are ways to bubble those up and do into parent scenes, parent components. In this case, as soon as I get the click close event, I'm going to close the relay. And if I get the open button event, I'm going to open the relay. And so those pressing close calls the first one here, pressing open calls this callback. So that's great. So now I know when someone presses a button, but how am I going to have the Scenic component actually drive the relay? And to do that, I want to use a library that comes kind of packaged alongside Scenic, but actually it's applicable outside of Scenic. It's a great, called Sensor. It's a great little pub sub library. Does all the things you'd expect. I can subscribe, I can publish, but it does it really centered around embedded devices, around a place where maybe only one thing is going to be publishing. I only have one sensor. So we'll start with going from the relay back to the component. So I want to know if that relay opens or closes. I want to be able to display that to the user, no matter what causes it. If a timer goes off, it's okay, great. I've got to start the sprinkler. I want to see it on the front end. And so, on the relay side, I have to set up. Sorry, it's out of order. I set up a sensor. I register that the relay gen server is going to be sending relay position sensor data. I then publish. I can go ahead and publish in the beginning because I know the relay position is open, so I'll just go ahead and tell anyone who's listening at that point in time, hey, the position's open. And then in these, when I'm handling the call for closing or opening, like we saw earlier, in the relay gen server, I just publish, hey, the relay position is now closed, relay position is now open. Anything subscribed gets an info message around that. So if we look back at the relay control, on the relay control, I subscribe to the relay position, and then I get an info message that I can match to relay position closed when the relay says, hey, I'm closed, and the same thing for when it opens up. And then in those, basically all I'm doing is modifying the graph. So if I see this closed, I'm going to change status text. Remember, we added a status text ID. I'm going to change that to say closed. I'm going to fill it green. And if I end up feeling open, just change it back to open. So that's one way. So now I know this sensor. I know what the state is of the thing in the field. I can change that on the front end. And finally, the other way, if I press the button, I want to be able to close or open the relay. And I'll say that using Scenic Sensor is not the most optimal way to do this. If we really want to do it right, we probably would have those relay processes, probably register them, be able to call it from other things. Scenic has a concept back when we had to do we had to actually register. When I register as a sensor, I can only have one process registered as that sensor. So if I want to have something else control the relay, this isn't the best way to do it, but for our purposes, for something simple, it works really well, kind of comes out of the box. So I want to use sensors from the button to control the relay. And so same thing, in my relay control, I register that, hey, I'm going to be the one sending relay commands. And then when that click happens, I just fill this in with publish relay command closed, publish relay command open. And those drive in the relay a handle info, relay command closed, command open. So I've got everything connected back and forth. And all in all, we've got really two relatively short files that define the entire relay lifecycle, all of the use case, all the failure modes around it. And I'll say it's very hard to find in another embedded development environment that'll let you do that much of a resilient control with such little amount of effort. So just to prove that it works, I can go and click. Sure enough, I click close. That sends the message to the relay, says close. Relay says, OK, I'm closed, and we update the state on the upper right. And if something else opens the relay, for instance, in the sprinkler example, I've got timers that are running. I have other reasons why I would start the sprinkler. Whenever that changes, the user sees that on the screen. So even if there's a gen server in the background that's actually calling and saying, OK, open the relay, that's being updated on the actual relay display at the same time. And finally, because it's a reusable component, if I wanted to put all 8 of these up on a screen, it's simply a matter of going back to that default scene and just adding a chain of these added graph with the offsets to the translates, and that's it. They all work exactly the same. So great. That's over. So how did it work? So first off, I'll show you what it looks like today. It's not done. There's a lot more I want to do with it. But as I saw before, this is kind of the screen for the touch screen. I've got a component, the custom components running each of the buttons. So I have a button that tells me I can press it, it runs the sprinkler. I can get the state, so if it runs on its own, it still shows up as running. The moisture data from that area, so in this case, it's a little low, it's colored orange. And then how much time is remaining on that schedule. So right now, it decided to run, and it's got 4 minutes left in its cycle. So all that's coming real time to the screen. I've also got components for each of the zones. These are actually part of a mapping component. So I built a small mapping component to render GIS polygons on inside of Scenic, using some fun math to make these into triangles. But effectively, it gives me an actual visual representation of which zone I'm talking about, where it is in the house. These shapes mean something to me. They don't mean necessarily much on the screen, but that at least tells me I'm not in the garage yelling, "Is that it?" while the neighbor's kids are getting sprayed with our sprinklers. I know exactly which one I'm setting off. So what about data? So this was before I switched over. So I let this run for my current sprinkler system while I was measuring the sensor data. So the lines here are the moisture percentages for the soil. And as I said before, I'm targeting somewhere around 40, somewhere up here in this area. Obviously, it's a bit dry. It's Texas in the summer. It's dry. At the bottom, I have bars every day for how much each of the zones was watered. And you can tell this is simply a timer every 3 days a week, watering so much for the yard. So once we switched over, we can see, hey, it did its job. It got the soil moisture up where I wanted it. It did it by spending a couple days doing a lot of watering to catch the soil up. But then after that, it really didn't have to do too much. This was a day we decided to move one of the sensors to a location that didn't look like it was getting rid of water, so it ended up deciding to sprinkle that sensor a lot. But all in all, worked really well. Basically, I had ideas for lots of big logic. In the end, all it does is every hour it looks at the moisture sensor, finds the zone that has the lowest amount of moisture, and just runs that zone for a couple minutes. And that's all it really had to do. And in the end, that means that I'm not watering zones that don't need it. I'm only watering little bits at a time, and that's enough to catch up with the summer. And I've also got there are a couple zones aren't shown here that are doing timer. We have a soaker hose that really can't get a moisture sensor on. So that's great. However, there's a bit of a caveat. That day when I decided to switch over also happened to be the beginning of the end of summer. So that's the temperature in Dallas, average temperature. So it's averaging 85, which means about 100 during the day, 90s during the day. And I just so happened to be in my desk pushing the last bit of this automation code as the first cold front of the year went through. So I don't know. I still think this is a good result. I'm not sure necessarily. It's hard to get a clear comparison, but I'm not sure if I am solving the problem of underwatering. I know for a fact I'm not overwatering now, which is great, especially when we've had these kind of rainstorms in Dallas. And the actual grass itself, which you showed, wasn't great, but now it's healthy and it's got more color to it. And so qualitatively, I guess, as admittedly not a good gardener, that looks like better grass. So did we do anything? Did we learn something? Useful practice? Yeah, I think there was a lot of learning on working with nerves. It's a great way to get back into, if you've been away from the more gen server OTP style, it's a great way to get back into OTP. It did happen that I was working on a project for work at the time that was building a live view system, and a lot of stuff that Sophie showed earlier, the idea of being able to send messages to control front-end UI, that more pure kind of OTP way of doing changes in the front end. That was very applicable here as well, similar patterns when dealing with Scenic. But did we build something that was useful and reusable and something I could make a business out of? Absolutely not. One thing about this project, it was an indulgence of impracticalities. There's a lot of hard-coded stuff in there, just made it quick. I've only got, this is all going to my personal G-Cloud account, there's no multi-tenancy. The number of zones where they lay out is fixed, but that's okay. And I think one of the things that was really nice about this project was we focus a lot on building things for immense scale of how many concurrent connections can I get to my server, how many requests per second can I handle. We don't get a lot of time to focus on, it's very freeing every once in a while to ignore all of that and just focus on solving a simple problem. And it's amazing how much faster you can go if you only ever care about one user. If you don't care about your second user, you can do a lot of really great stuff very quickly. But that's okay, and there's a lot of things that we can do now with the availability of things like Nerves that I couldn't do 5-10 years ago, and make it practical for me to do at home. And I really would encourage everyone to find projects like that. I think it's important we kind of get out of the typical way we think about building scalable systems and just focus on the individual problems. And did we did a better lawn through Elixir? Yes, I think we did a better lawn through Elixir. One more thing about the indulgence of impracticality. My wife, who's had a very pragmatic point, which just says, what happens if we sell the house? And all of a sudden you have this Frankenstein system. I said, well, we'll just sell them a consulting agreement with the house. So yeah, I think we did a better lawn. There's a lot of stuff I want to do with it. One, I'd like to go through a real Texas summer. We had 100, however many days of over 100 degrees, no rain for months. I think it'd be fun to see if compare, now they have data on the soil moisture and the water consumption for summer. I'd like to see how that compares when I actually handle it properly with this. I'd like to add some water flow metering. Something I wanted to do I didn't have time to finish up, which was be able to know not just, if I have GIS, an actual polygon of what my lawn looks like, I should know how big it is. I should know how much water per square foot I need for that, and be able to meter the water based on volume, not just based on time. So again, tightening up that control loop just a little bit more. We're not controlling for time. I want to actually know how much water should I put on the lawn. Using APRS or some of the predictive weather, so something like dark sky or these APIs where I can pull, hey, how much is going to water later? If it's going to rain in an hour, then don't water right now. Things like that. And finally, more sensors. We need more data. I want to be able to put lots and lots of sensors out there. We've got a couple, putting just in different parts of a given zone and try to target getting the whole zone to kind of an average level. Always need more data. So that's it. Thank you very much for staying with me after lunch. I think we have time for questions, maybe? No, it's okay.
Yeah, we have time for questions. Do we have any questions? Way back.
How do you power your sensors?
They have just a small battery inside. They're Zigbee, so pretty low current or low usage. I think they only power on if they see a change in the capacitance.
Since you mentioned not building for the second user, did you build in any type of authentication between your sensors and
Nope. Well, Zigbee has a certain amount. Obviously, that's not completely secure, but there's a certain amount of that setup that has some authentication. But Zigbee's not known for being particularly resilient for that.
Right. Follow up. What'd your water bill do? To go up or down?
I need to look. It should have gone down, but again, it's kind of that time of year when it goes down anyway. So we could probably look at yesterday's. I will say for security around the sensors, I guess more around maybe speaking about, I don't really care if someone sees how my lawn's moisture level is, but someone potentially could run a fake sensor, force it low, and have me run water. I did put some logic in there. It only runs at most a minute an hour, I think, or 2 minutes an hour, something like that. And then part of maybe what's next with the metering is we get our nozzles on our sprinkler system get broken off all the time. So knowing that, hey, I ran it for a minute and you dumped a gallon of water, versus I ran for a minute and you dumped however much, then detecting those types of anomalies. I'd rather detect those kind of wholesale.
Any other questions? Well.
How are you pulling in the APRS data?
So there are APRS FI is an online database that captures all of that and stores it. So I just pulled the latest one from that station. I would love to do it more straight off the radio, but it's down the list of priorities, I guess. Plus, it means putting an antenna on the house, and that gets into the whole, well, I've got to buy more tools, and it's going to get more expensive. And another antenna on the house, and there's barriers to that. No, actually, we don't. But I have other forces in our house that would like not to see a lot of antennas sticking out our roof.
Anybody else? Okay, thanks, Powell.
Thank you very much.